The electrician's exam taken in Downers Grove, Illinois, is accepted in all surrounding towns in Illinois, including Cook, DuPage, and Will counties. You can obtain your license in Downers Grove and subsequently work in various towns such as Burr Ridge, LaGrange, Burbank, Oak Forest, Tinley Park, and Orland Park. In addition to Downers Grove, there are other testing sites for the electrician's exam in Illinois. These include Chicago in Cook County, Schaumburg also in Cook County, Bolingbrook in Will County, and Springfield in Sangamon County. The electrician's exam in Illinois comprises 60 questions. The cost to take the exam is $200. For more comprehensive details about the exam, consult the Illinois Department of Labor's website at. The electrician's exam in Illinois covers both residential and commercial electrical work. A separate exam specifically for residential electricians is not available. If you need additional information, contact the Illinois Department of Labor at 312.793-2800 or visit their website at / When preparing for the Illinois electrician's exam, it's crucial to understand the scope of the examination, which encompasses both residential and commercial electrical work. This means you should be knowledgeable in all aspects of electrical installations, maintenance, and repairs in both types of settings. The exam assesses your understanding of the National Electrical Code, commonly referred to as the NEC, as well as local electrical codes and regulations specific to Illinois. It is important to familiarize yourself with the most recent edition of the NEC, as this is what the exam questions will be based on. To effectively prepare for the exam, consider the following steps. Firstly, obtain the current edition of the NEC and thoroughly review its articles, tables, and definitions. Pay close attention to articles related to general wiring, wiring methods, equipment grounding, overcurrent protection, and specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. Secondly, study the Illinois Electrical Code, which may include amendments or supplements to the NEC. These local codes may have specific requirements or restrictions that differ from the NEC, so it's important to be aware of them. Thirdly, practice with sample exam questions and practice tests. This will help you become familiar with the format of the exam and the types of questions that are asked. There are several resources available online and in libraries that offer practice exams and study materials. Fourthly, consider taking an electrician's exam preparation course. These courses are designed to provide you with the knowledge and skills you need to pass the exam. They typically cover topics such as electrical theory, code calculations, and practical wiring techniques. Fifthly, familiarize yourself with electrical testing equipment and procedures. The exam may include questions about using multimeters, voltage testers, and other tools to troubleshoot electrical circuits. Sixthly, understand the principles of electrical safety and follow safe work practices. The exam will assess your knowledge of safety procedures such as lockout-tagout, personal protective equipment, and arc flash hazards. Seventhly, review basic electrical theory, including Ohm's law, Kirchhoff's laws, and series and parallel circuits. This will help you understand how electrical circuits work and how to troubleshoot problems. Eighthly, understand the different types of wiring methods such as conduit, cable, and surface raceway. Be familiar with the installation requirements for each type of wiring method. Ninthly, study the requirements for grounding and bonding electrical systems. Proper grounding and bonding are essential for electrical safety and preventing electrical shock hazards. Tenthly, learn about overcurrent protection devices such as circuit breakers and fuses. Understand how these devices protect electrical circuits from overloads and short circuits. The Illinois Department of Labor's website, which you mentioned, is an excellent resource for information about the electrician's exam. You can find information about exam eligibility requirements, application procedures, exam content, and testing locations. You can also download a candidate information bulletin, which provides detailed information about the exam. When you arrive at the testing center, be prepared to present identification and follow the instructions provided by the proctors. The exam is typically administered on a computer, and you will have a limited amount of time to complete it. During the exam, Read each question carefully and choose the best answer. If you are unsure of the answer, it is best to make an educated guess rather than leaving the question blank. After you complete the exam, you will receive your results immediately. If you pass the exam, you will be eligible to apply for an electrician's license in Illinois. If you fail the exam, you can retake it after a waiting period. Remember that the Illinois electrician's exam is designed to assess your knowledge and skills as an electrician. By thoroughly preparing for the exam, you can increase your chances of passing and obtaining your electrician's license. Specific areas of knowledge that are crucial for success on the Illinois electrician's exam include, firstly, calculations related to Ohm's law, power, and voltage drop. These calculations are fundamental to understanding electrical circuits and ensuring safe installations. Secondly, the proper sizing of conductors and overcurrent protection devices for various applications, based on ampacity tables and correction factors found in the NEC. Thirdly, understanding grounding and bonding requirements to prevent electrical shock hazards and ensure proper equipment operation. Fourthly, knowledge of wiring methods and materials, including conduit types, cable types, and their appropriate applications. Fifthly, familiarity with electrical equipment such as transformers, motors, and control systems. Sixthly, safety procedures and practices to prevent electrical accidents, including lockout-tagout, personal protective equipment, and arc flash protection. Seventhly, the ability to read and interpret electrical drawings and schematics. Eighthly, understanding the NEC requirements for various occupancies, such as residential, commercial, and industrial buildings. Ninthly, troubleshooting electrical circuits and equipment using appropriate testing instruments. Tenthly, knowledge of energy efficiency and renewable energy systems. Furthermore, it's beneficial to understand the different types of electrician licenses available in Illinois and the requirements for obtaining each one. The Illinois Department of Labor offers several types of electrician licenses, including firstly the electrical contractor license, which allows you to bid on and perform electrical work. Secondly, the supervising electrician license, which allows you to supervise other electricians. Thirdly, the journeyman electrician license, which allows you to perform electrical work under the supervision of a supervising electrician. Fourthly, the residential electrician license, which allows you to perform electrical work in residential buildings. To obtain an electrician's license in Illinois, you must meet certain requirements, such as completing an apprenticeship program, passing the electrician's exam, and having a certain amount of experience in the electrical trade. The specific requirements vary depending on the type of license you are seeking. In addition to the technical knowledge and skills, it's also important to have good communication and customer service skills. As an electrician, you will be working with customers on a regular basis, so it's important to be able to communicate effectively and provide excellent customer service. This includes listening to customers' concerns, explaining electrical issues in a clear and concise manner, and providing prompt and reliable service. Furthermore, it's important to stay up to date on the latest electrical codes, regulations, and technologies. The electrical industry is constantly evolving, so it's important to continue your education and training throughout your career. This can be done by attending industry conferences, taking continuing education courses, and reading trade publications. Finally, it's important to be a professional and ethical electrician. This means following the NEC and other applicable codes and regulations, providing honest and reliable service, and treating customers with respect. By following these principles, you can build a successful and rewarding career as an electrician in Illinois. Keep in mind that the information provided is a general overview of the Illinois electrician's exam and licensing requirements. For the most accurate and up-to-date information, always consult the Illinois Department of Labor's website or contact them directly. In preparing for the electrician's exam, one often encounters questions related to conductor ampacity and dating factors. Conductor ampacity refers to the maximum current, in amps, that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The National Electrical Code provides tables that list the ampacities of various conductors based on their size, insulation type, and installation conditions. However, these ampacity values may need to be adjusted based on factors such as ambient temperature, the number of conductors in a raceway or cable, and the presence of harmonics. Dirting factors are used to reduce the ampacity of a conductor when these conditions exist. For example, if a conductor is installed in an area with a high ambient temperature, its ampacity must be reduced to account for the increased heat. Similarly, if multiple conductors are bundled together in a raceway or cable, their ampacity must be reduced to prevent overheating. The NEC provides tables and formulas for calculating dirting factors under various conditions. It's important to understand how to apply these dirting factors to ensure that conductors are properly sized and that electrical systems are safe and reliable. Another important aspect of electrical work is understanding voltage drop. Voltage drop refers to the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction, reduce the efficiency of electrical systems, and even create safety hazards. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. To calculate voltage drop, you need to know the length of the conductor, its resistance per unit length, and the current flowing through it. The NEC provides formulas and tables for calculating voltage drop under various conditions. It's important to consider voltage drop when designing electrical systems to ensure that equipment receives adequate voltage and operates properly. Grounding and bonding are also critical aspects of electrical safety. Grounding refers to connecting electrical equipment to the earth to provide a low impedance path for fault current. This helps to protect people from electrical shock and to prevent damage to equipment in the event of a ground fault. Bonding refers to connecting non-current carrying metal parts of electrical equipment together to create an electrically conductive path. This helps to equalize the voltage between different parts of the equipment and to prevent electrical shock hazards. The NEC provides detailed requirements for grounding and bonding electrical systems. These requirements cover topics such as grounding electrode systems, equipment grounding conductors, and bonding dampers. It's important to understand these requirements to ensure that electrical systems are properly grounded and bonded. Overcurrent protection is another essential aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overloads occur when the current in a circuit exceeds its rated capacity, which can cause the conductors to overheat and potentially start a fire. Short circuits occur when there is a direct connection between two conductors, which can cause a large amount of current to flow and damage equipment. Circuit breakers and fuses are designed to interrupt the flow of current in the event of an overload or short circuit. The NEC provides detailed requirements for overcurrent protection, including the types of overcurrent protection devices that are permitted, their interrupting ratings, and their coordination with other electrical equipment. It's important to understand these requirements to ensure that electrical circuits are properly protected. Wiring methods and materials are also important considerations in electrical work. The NEC specifies the types of wiring methods that are permitted for various applications such as conduit, cable, and surface raceway. Each wiring method has its own advantages and disadvantages, and the choice of wiring method depends on factors such as the environment, the type of occupancy, and the cost. The NEC also specifies the types of materials that are permitted for use in electrical wiring, such as copper, aluminum, and steel. The choice of material depends on factors such as the ampacity, the corrosion resistance, and the cost. It's important to understand the NEC requirements for wiring methods and materials to ensure that electrical installations are safe and compliant. Electrical equipment such as transformers, motors, and control systems plays a critical role in many electrical systems. Transformers are used to step up or step down voltage levels, which is necessary for transmitting and distributing electrical power efficiently. Motors are used to convert electrical energy into mechanical energy, which is used to power a wide variety of equipment. Control systems are used to regulate the operation of electrical equipment, such as lighting, heating, and air conditioning. The NEC provides detailed requirements for the installation and maintenance of electrical equipment. These requirements cover topics such as overcurrent protection, grounding, and wiring methods. It's important to understand these requirements to ensure that electrical equipment operates safely and reliably. Safety procedures and practices are essential for preventing electrical accidents. Electricians should always follow safe work practices such as lockout-tagout, which is a procedure for de-energizing electrical equipment before it is worked on. Electricians should also wear personal protective equipment such as safety glasses, gloves, and insulated tools to protect themselves from electrical hazards. The NEC also provides requirements for arc flash protection, which is designed to protect electricians from the intense heat and pressure that can be generated during an arc flash. It's important to understand these safety procedures and practices to prevent electrical accidents. Reading and interpreting electrical drawings and schematics is a crucial skill for electricians. Electrical drawings and schematics are used to represent electrical systems in a graphical format. These drawings and schematics show the layout of electrical circuits, the location of electrical equipment, and the wiring connections between different components. Electricians must be able to read and interpret these drawings and schematics to install, maintain, and troubleshoot electrical systems. The NEC provides symbols and conventions for creating electrical drawings and schematics. It's important to understand these symbols and conventions to be able to read and interpret electrical drawings and schematics accurately.